Yeah. Hello guys, I am Tarun from Chemical Department at IIT Madras. Now I am going to discuss about course ME1100 thermodynamic course. So now let's discuss module 1. So this is the course introduction and these are some points of course introduction and yeah. And now let's see basic definition. So first, system and surroundings. So a system is defined as a fixed mass of matter on which attention is focused. The rest of the universe, which lie outside the system, is called the surrounding. So in this is layout of system. Sorry, this is layout of system. Yeah, this is boundary that separates system and surrounding. Next, now, system. So the system boundary can be a real or an imaginary boundary, and the shape and the size of the boundary can change with time. So the size of the system can be changed. So remember, the system is always defined for a fixed mass. It means no mass transfer can occur between the system and the surroundings. So these are some examples of the system: an electric bulb, photo, photovoltaic solar cell, and nuclear power plant, etc. Now control volume. So the energy as well as mass transfer can occur between the system and surroundings. Now this is the layout of control volume, and this is boundary of control volume. So this is inlet stream, and this is outlet stream. Okay. So now property and state of the matter. So now let us discuss first intensive property. So independent of mass of the system. So intensive property are like pressure, temperature, density, and second one is extensive property. So that is so extensive property are dependent on size or mass of the system. So examples like volume, potential energy, kinetic energy. So now a state represents the collection of all properties of a system when the system is in equilibrium. Next, equilibrium and process. So when no change in any of the properties occurs, when the system is isolated from the surroundings, then the system is said to be in thermodynamic equilibrium. And a process is the sequence of states followed by a system. The locus of the process is known as the path. Next one is quasi-static process. So a slow process that goes through several intermediate like several equilibrium state. So intensive properties are defined only in quasi-static process. Now exact or inexact differences. So let us consider a function alpha. Let us consider a variable alpha that is a function of x and y. So in this case, so in the case of exact differentials, so we can write the d alpha equals to del alpha by del x at y constant into dx plus del alpha by del y at x constant into dy, and we can further rewrite as a dx plus b dy. Here here uh, here and here also del a by del y at constant x and del b by del x at constant y. Also these are also equal. Now pressure. So for a fluid at rest, pressure exerted in same is same in all directions, and the normal component of the force exerted per unit area, no, Newton per meter square, is called the pressure at that unit area. At that unit area. Okay. So the commonly used manometer. So these are some instrument to denote the pressure. Na- Nanometers, Bourdon gauge, and barometer to measure the process pressure. This is mercury barometer, and this is U2 manometer. Here, Here in this end, the pressure of this end is equal to the atmosphere pressure, and this is P in. This is pressure of system that we are going to measure. Now work. So let's discuss work. So the mechanics definition of work is simple: force into distance, so F into S. And the thermodynamics definition we can write like work is done by a system during an interaction. So work is an energy interaction between the system and the surrounding, and we can say when a system transfers energy in the form of work, it does positive work. At that same time, surroundings will do an equal amount of negative work. So we can say W work done by system plus work done by surrounding. So this sum will always zero. Now displacement work when piston moves a distance dx. So so this is PM bit atmosphere pressure, or here this is P system pressure. So when P greater than P emit, so net work interaction between piston and surroundings, we can say if let's say W1, so W1 equals to P emit minus P into A into dx, and work interaction between atmosphere, air, and the surrounding. Let's say W2. So the W2 equals to minus P external, that is P ambit into dV, that is A dx. So work interaction between the gas and the surroundings W3, so that we can write P into A into dx, P dV. So now we can write total work. Total work W1 plus W2 plus W3. So the sum of all these forces are zero. Now work done during different thermodynamic process. So process where first process pressure equals to constant. So we can write work done during path 1 to 2, yeah, or we can say process where the state goes 1 to 2. So we can write pdv, integral pdv from 1 to 2. So simply we can write, if pressure is constant, then we can write p into v2 minus v1, where, and second one pv equals to constant, where we can write pressure like this. Third one pv power n constant, where we can write work done like this. Last one volume constant. When volume constant, so work done will be zero. Now these are some other form of work: spring work, electrical work of capacitors, electrical work of resistors, shaft work, and lifting of a mass m by height h. We can say gravitational work. Now thermal equilibrium and zero flow. So when two bodies at different temperatures are brought into contact, after some time they attain a common temperature. So they are now, when they attain a common temperature, in that situation we can say these two bodies are in thermal equilibrium. And now zeroth law. So if system A is in equilibrium with system B, and further system B is in equilibrium with system C, so then directly we can say system A must be in equilibrium with system C. Now temperature. So temperature is an intensive property, we already know, and doesn't depend on the quantity of matter. So these are some instrument to measure temperature. Now temperature unit. So these are some conversation between the units of temperature. Here we can convert temperature from Fahrenheit into degree Celsius and some like other one. Now mode of heat transfer. How heat transfers? So heat, first one is conduction. So where rate of heat transfer, we can write minus Ka into dt by dx. Dt is temperature difference, and dx is a displacement element. So now the second one is convection. Third one is radiation, and the units of heat transfer should be joule per second. We already know. Here q dot is heat transfer rate. Yeah. So no, remember, this is we are taking rate of heat transfer, not heat transfer. Now let's discuss first law of thermodynamics. So for cyclic process, we can write first law del Q summation Q minus summation W equal to 0 for cyclic process. In cyclic process, change in internal energy will be 0. Now for non-cyclic process, simply we can write Q minus W equal to delta U. So in the non-cyclic process, the energy of the system increases when the energy entering the system is more than the leaving the system. So Q, so Q is more than W. So in this condition, the internal energy will be changed. Now total energy E. So the total energy is sum of different forms of energy. We can say different form like kinetic energy, potential energy, electrical energy, and etc. So now we can write change in total energy something like this. Now specific heat. So the specific heat at constant pressure we can write like this Cp. So where Cp is equal to del H by del T at constant pressure, and at constant volume we can write Cv, where Cv is equal to del U by del T at constant volume. Okay, so this was module 1. Thank you.